What's my least favorite part of running a Bridgeport-style milling machine? It's got to be running the crank for the Z-axis, moving the knee and the table up and down. In this video, we're going to take a look at the Align Z-axis severe duty power feed from Precision Matthews. Gavin Gu here for makingwithmetal.com and ultimatereloader.com. In this video, I'm going to unbox the Align severe duty power feed for the Z-axis on my Precision Matthews PM-949TV Bridgeport clone milling machine. I'm going to take it out of the box. I'm going to walk you through the installation at a high level, and we'll do a quick demo. So let's get this machine out of the box. If you go to precisionmatthews.com and you look at the product page for the particular mill you're interested in, they're going to list the accessories. That's where I found this. They have a regular duty and a severe duty. This is the severe duty model. If memory serves me correctly, it puts out about 760, 780 inch-pounds of torque where your handle would normally go, and I call that impressive. And it's going to save me a lot of pain and anguish. We've got some washers here. Looks like we've got the block for the safety limit switches. There's the limit switch bumps. Okay. That might be the shaft extension. Yeah. We're going to still be able to use the manual crank, of course, and that's an important consideration. Stuff looks really nice so far. Okay. Ooh, yeah. That's what I'm talking about. Sight for sore eyes. Okay. And we've got the tracks for the limit switches. Let me get this cleaned up. We'll walk through everything that's included with the kit. Then we'll head over for the installation. So here's the contents of the Z-axis power feed kit laid out so that you can see everything a bit more clearly. We've got mounting hardware and shims. We've got the limit switch assembly and bumpers. We've got the shaft that we're going to replace. This has the splined collar that's going to interface with the factory crank so that we can either crank or use the power feed. And of course, we've got the feed itself. Before I get to that, we've got the T-track itself that's used to position the bumpers for the limit switch assembly. These bumpers are going to hit the switches here on the switch box, and when we get to the very top of our defined travel for the table, and when we get to the very bottom for the defined travel for that knee and table, we're going to automatically shut off the power feed. So it's an important safety mechanism. Overall, this looks really beefy, and like I said, it's made in Taiwan. This is not a Chinese unit. This is a severe duty unit. It's got really nice handle operation. There's a rapid traverse so that we can rapid up and down. We've got the speed control knob, the on-off switch, and a circuit breaker. So, complete kit, and what I'm going to do next is go over to the Precision Matthews PM-949TV, take a look at things, start to get it torn down, and then I'll walk you through the process of installing the unit section by section. So I just literally finished installing the power feed unit itself. I've still got to install the limit switch assembly. We're going to get to that to give you an idea of how this works. There's a power switch down here at the bottom. Up, we can adjust the speed dynamically on the fly with this knob. Down, we've got rapids. By holding the rapid switch down, you do want to wait until the internal mechanism stops before reversing. Real nice unit. And the first steps are to just take off the knee crank outer components. And what you'll do is take off the handle. This castle nut assembly is just slipped off for me. Sometimes people need to pry those a little bit. There's a woodruff key, you're going to remove that. The nut for the dial, you can see the dial here. Those two are going to come off. Then there's this collar. This collar was a little bit tight, if memory serves me correctly. I put the castle nut and key back on and then used the handle and some pliers to loosen this collar. And then there's the bearing retainer cap. There's 3 Allen screws that you remove to pull this out. That's all there is for disassembly. For the installation, I did follow the instructions that come with the unit, but there really are just a set of two-dimensional cross-sectional drawings, and that was one of the reasons I wanted to do this video, was to provide a little bit more information. It's relatively straightforward, but there's some things that you have to pay really close attention to. The first thing you're going to do is to take a shaft extension and screw that on. That comes with this power feed assembly, and then there's a replacement bearing retainer cap that has tapped holes that are used to mount the power feed assembly. So that goes on. I used the same screws, the countersunk Allen screws that were used to hold the factory bearing retainer on. At this point, you can slip the housing of the power feed onto the shaft. There's a needle roller bearing that's pressed into the inside. You want to be careful to get that on the shaft extension on the machined portion and have it slide up. Initially, I thought I had a clearance issue, but I noticed that the fit between the casting on the knee and the housing is really tight, and you actually have to rotate it so that it will move out of the way and seat all the way between the housing of the power feed and the bearing retainer cap that comes with the power feed assembly. There's two Allen screws. On this mill, it was perfectly rotated. I'm guessing Precision Matthews did that on purpose. I put those two Allen screws, two that are included with the set, to a medium level of torque, and then torque them down with an Allen key to secure this guy firmly in place. Then we can take the bronze bevel gear and test that for backlash. What you want to do is push that onto the shaft extension, but you don't want to put the Woodruff key in yet, because we're going to see how much backlash there is between the bronze gear and the bevel gear down here in the power feed assembly. It's kind of like a ring and pinion type of a thing if you're familiar with differentials on cars. And so what you want to do is get just a little bit of backlash so that things aren't too tight. And I had to use a couple washers. There's smaller washers and larger washers that come with the kit to get that backlash set and to get it to where I was comfortable with it. Then we put on the dial and then check to see if there's interference. Mine was a little close, so there's a set of larger washers, shims, that come with the kit. And I put, I think, about 6 of those on to get a nice little gap all the way around when the dial nut is tightened. It's going to function just like it did with the crank only assembly. We can loosen and tighten the nut, and then that can be used to reset it or to let it freewheel. So when I got those shims on, I put the nut on and was happy with how that was working. It's then time to screw on the castle nut that comes with the power feed set. And I used the crank handle, this whole crank assembly, to screw it onto a medium level of torque, and then to raise and lower the knee manually to make sure that the entire mechanism was operating freely and not binding up on anything. You then tighten the castle nut. What I did is I tightened down my knee locks for the Z-axis and then cranked it a bit just to make sure that it was snugged up. Now, prior to this, I had cross-drilled the lower part of this back flange on the castle nut with an 8mm drill. This is per the instructions. It's not very clear in the instructions what they mean by install check clutch against bevel gear, then drive through one hole of 5mm diameter. What that means is install the castle nut, and when you're happy with the fit, cross drill a 5mm hole, then drive spring pin, it says. Then install the roll pin. I used a roll pin punch for this and put it all the way through. My hole went through cleanly because I had pre-drilled, and then of course on the mill here with it tightened down, I had to drill through the shaft using the hole that I had drilled on my 728 VT as a guide. That way I was sure that I was going to exit at the appropriate point. So that secures the castle nut to the shaft extension. At this point, it's just a couple really easy final assembly steps. We're going to slip the crank handle on with the spring in place. That's going to make sure that the crank is disengaged so that when we operate the power feed, it doesn't swing the crank handle around and knock us. Could be something really unfortunate there. There's also a washer back here and an Allen screw that secures the entire assembly here. So you do have to push in, and then, you know, it'll operate pretty much normally. You got to keep a little bit of inward pressure, and I'm still getting used to that. So that's a minor inconvenience. I'll easily pay that tax to have a Z-axis power feed, because the table and the knee is really, really heavy, and it gets really tiring to crank that up and down. Okay, so that is the installation of the actual power feed unit. Next, I'm going to go on to the limit switches. And now I'm completely done with the Z-axis power feed install, including the limit switch, the brackets, and the bump stops. And I have to say, it could take you as long to install all of the safety hardware as it does to install the power feed itself. The first thing you're going to need to look at is which side of the knee you want to put it on. I already had a Z-axis DRO scale on the right-hand side of the machine, so I chose the left-hand side of the machine. And the biggest challenge I had was the casting on the column has curvature at the bottom and is relatively flat on the top. So the first thing I did was to assemble the two-piece rail assembly. There's a steel strip, so there's 4 screws total that holds this track together. The track is where the bump stops are going to slide, and you can adjust exactly where they are set. Then I took a look at the overall travel. This machine has almost 17 inches of Z-axis travel. Of course, then you have your quill as well. So I put pencil marks on both the knee and on the column where it was at the bottom, very carefully bottomed it out with the hand crank, and the same thing up at the top. It could probably have gone a little bit higher, but the table was almost touching the bottom of the spindle here, and I don't ever plan to raise the table that high. And that corresponded to roughly the amount of adjustment that you're going to have, the overall travel for the limit switch with this length track. So that worked out good. It was then a matter of where exactly am I going to put the limit switch assembly itself, and I had to decide kind of how to straddle some of this tubing here from the one-shot lube system, and didn't take too long, figured out where I wanted to put that. Then I prepared the bottom hole in the casting. I never like to drill into my machine, but this is one of those cases where I had a total of 4 holes, all of them 1/4-20 I ended up drilling. Now on the bottom, like I mentioned, there was curvature there. So what I ended up doing was kind of getting my center punch to impact the hole to make a little divot. And then I took a very small diameter drill bit, walked in sort of perpendicular to the curvature, and then worked my way so that I was drilling kind of straight in. After drilling I think this is about 186 thousandths of an inch hole, I used a counterbore with 186 thousandths of an inch pilot. The counterbore is kind of like a milling cutter with a pilot in the middle. And so you can take a hole, you can follow it in, and you can bore it flat. And that's exactly what I wanted here, because I planned to use cylindrical spacers, both to stand off this limit switch bracket and for the limit switch assembly itself. So I counterbored the hole. I drilled it with the number 7 drill bit, which is the appropriate pre-drill for 1/4-20 tapping. I tapped the hole. I cut a screw down on the lathe, cut the head down so that it would fit in between the channel. This is just a straight slot, kind of pan head, and tightened it up. That showed me exactly where I needed to be on the upper side. Now I had already measured it, and it turned out I was within probably a 32nd of an inch. So I used a transfer punch to do my center punch up at the top, and then I took the entire bracket off, tapped it for 1/4-20, turned down the appropriate spacers on the lathe with a 1/4-inch hole in the middle. It turned out I was 0.6 inches on the outside for that. Took some careful measurements to figure out how long each one needed to be. Remember, I've counterbored down here and I'm on the flat casting surface up here in order to have that constant gap on the back side there. And I had to carefully set things up so that it was perfectly parallel with the way cut out. So that was a little bit tedious. Then it was time to mount the limit switch box itself. And I had done a ton of research online looking at the different switches and their different configurations. Not a lot of information available. There was an aluminum cast bracket that turned out, it looked like that was actually for a Y-axis setup, something like that. So I ended up taking the box off of the bracket and flattening the bracket. It was at an angle, about 20-degree angle or so. And so I carefully bent it and then used the vise to kind of flatten it so that it was roughly flat. And that allowed me to measure what length standoffs I needed. This is 7/8 OD tubing, had an oversized hole. That was fine. I held the limit switch box kind of where it would need to be centered on the bump stops. And then it was just over 2 inches each. Parted those off to length, adjusted them a couple of times to get everything perfect. And then I was very careful. I took the knee locks out to see how much depth I would have before I could potentially interfere with the tapered gib or anything like that, because these locks lock down against a gib. So I took my 0 to 6 inch digital caliper, measured the depth. It was about 0.6 up here and about 0.75 down there, because again, it's a tapered gib. And so I drilled my holes about 0.45 deep, just to be a little bit on the safe side. And I like to start the tapped holes with a 2-flute tin-coated sort of through-hole style tap, a really nice Cleveland twist drill, one that cuts really, really good. And then I chased that with a bottom cutting tap, a plug tap, and that gets the thread depth to their maximum depth possible based on the pre-drill that you've done. Blew those out, bolted down the bracket, and then tested the limit switches. What you want is to run your power feed, and you want for it to be able to be on the rapid setting and for it to shut itself off when it hits the bump stop without causing excessive compression or anything like that. If you have everything lined up, there should be no problems, but that's an important consideration. This is a really good fail-safe to make sure that we don't go too low or too high and damage either the power feed or the machine. So this takes quite a bit of planning and a lot of attention to detail and some patience, but once you get it mounted, you shouldn't ever have to worry about it again. For cable routing, I used some zip ties to tie the 2 cords together, and then where I had a manifold and some tubing for the one-shot lube, I had multiple attach points there. I'm going to leave this kind of hanging free. It's going to go up and down with the machine. If it catches on the bump stop, I might have to do something to hold that out and away from the limit switch bracket and assembly. So that concluded the install. I would say if you have this video to go off of, depending on the complexity of your limit switch bracket, you're going to probably spend, figure, 2 to 3 hours on the install total. That's it for this Align Z-axis power feed install. Instructions should be good for pretty much any Bridgeport machine or Bridgeport clone. There might be some differences with the assembly here that you're going to have to tackle and encounter, but a lot of the Bridgeport clone machines are going to be exactly like this. And I hope the video was helpful for you. If it has been, please give it a thumbs up. Don't forget that first link in the video description is going to have an article with pictures from this video and other pictures, a complete write-up to help you with even more detail if you like to read things, if you'd like to study the pictures, that kind of thing. Have you mounted a Z-axis power feed on your Bridgeport type mill? Please drop a comment and we'll start a discussion. Do you have questions? Again, please drop a comment and we'll start a discussion. Don't forget to subscribe with notifications, because I've got a lot more great metalworking content coming up, a lot more Precision Matthews features. If you're interested in buying one of these power feeds, there's going to be a link down there in the video description as well. Don't forget, I got Ultimate Reloader shirts at the Ultimate Reloader store. I'm on Patreon, links in the video description. Thank you for watching. Until next time, happy metalworking.